Okay, now you've learned from the first video how to open up Emacs and open up C code in Emacs and then open up a command window and compile your code. Don't expect you to be expert in that yet, but hey, you can always go back to that video and watch it again. Now what I'm going to do is take you through what I hope is a fairly brief tour of the starter.c program. What I've done is I've written this program, does this just very simple thing, presents red and green circles, records how quickly you can push left or right for red or green, and records that data for you. So just the simplest possible program, really. And what I've done is I've gone through and line by line, you can see here these double slashes are a way to comment things out, to put comments in your code. And so and also the /*/ is a way to offset an entire chunk of space for a comment that now will be ignored by the compiler when it goes to compile this as code. And this is a way for you to write notes to yourself about what's happening in a particular place. And what I've done is I've gone through this entire program and just put in tons and tons of these comments, almost, not quite, but almost line for line to tell you what each piece of the code is doing. And so I'm hoping that you can kind of read through it yourself. I know you can't read it like a book. I still have trouble sometimes reading other people's code and knowing what's going on. Actually, even sometimes my own code. And remembering, like, what did I do here? How does this code work? It's not always intuitive. But anyway, I'm hoping that you can at least see yourself how the program is put together. What I'm going to do now is just briefly go through all the major bits of a C program and just kind of point out some of the highlights. So the first thing we want to do is include our libraries. These are we do this with header files. The .h here at the end of each one of these means a header. And what these do basically is provides a set of functions that now have commands in them that we can now use in our C code to call things. So for example, the Allegro header points to the, I don't know if points to is the right word, but anyway, it enables the Alleg42 DLL file, which enables all the commands in Allegro, things like draw circ, circ fill, rect fill, that allow us to draw shapes and give them color and so on the screen. Also, there's just tons of stuff in the Allegro library. So that's what these headers do. Here, it's always helpful if you'll just write yourself a note about what your program is doing, yourself and anybody else who might ever look at your code. Next are the definitions. These are constants that we can now call or refer to in any function in our code. And so, for example, in a function, if I write in all caps trial, that will stand in for the number 8, and the function will understand that by trial I mean 8. And I will understand that by that I mean the number of trials whenever I use trial here. And so, through some of our tasks that I have on that, sort of programming tasks to get you started changing this program to learn how programming works, you'll interact with some more definitions. All right, the global variables. You don't have to always use global variables. And they can be kind of dangerous because if you change them in one function but need them to still be the same value in a different function, that can cause your program to either crash or to not behave the way you think it ought to. So you always need to be careful with these global variables. Variables that are not global, they're declared within a function, and only that function can change the value of them, only that function recognizes them as variables, and so on. So that's usually safer, but there are some times when we need global variables. One that we need whenever we're going to time anything is the volatile integer counter. And what we're down right here in the function, my timer handler, we're going to set counter to incrementing once every millisecond. And that helps us to keep track of the when things happen in our experiment. Okay, so we need that if we're going to time anything. For example, if you want to time your subject's responses. Here we have a couple of things that I've found handy to have as global variables rather than as locally defined variables. The trial RT, that's the reaction time, and it's actually not a variable, it's actually an array, which means a set of values, not just one value. So this one has trial values. Trial RT has trial values, where trial up here, remember, was defined as 8. And so that means if I ever need more values in trial RT, I just go up here and change my definition of trial to be more, and it will automatically change the number of trial RT, the number of resp time. Resp time records the actual clock time that a response was collected on trial, and it's used to calculate trial RT within a trial. The reason for making these global instead of local is that a function can only pass to another function one value, but I need a trial to do things like record the time of the response and the reaction time and the identity of the response, whether it was a left or a right or whatever. And so because I need it to record multiple things, I need at least some of those things to be global variables so that they don't have to be passed back to another function. They can just be read out by that function anyway because they're global. All right. The function main is kind of the home base. It's the first thing that any C program is going to do is the things that you've told it to do in the main function. The main function is the one that you're primarily going to use to call other functions to do things like do a trial, evaluate a response, that sort of thing. Here we have variable definitions, or declarations, I should say. We define some ints I and j to be counters. We define then some more ints to be other stuff, some character variables. I don't think I have any float declarations here, but a float variable is just a variable that is a continuous variable, so it has a decimal place, and like 3.7, 4.2, those would be float numbers, as opposed to integers, which have to be whole numbers, like only 1, 2, and 3, not 1.5. All right, and then some other things, structures, I think they're called, file, and this is actually not a file itself. This is the star here. The asterisk just tells me that this is a pointer to something called FP. I don't really understand pointers. By the way, I should point out I'm not a real programmer, and I don't pretend to be. I can program just well enough to program psychology experiments, usually pretty simple ones. My programs, I don't make them look pretty or anything. I just make them look the way that they have to look in order to collect the data that I need. So, I don't know how to explain a lot of this stuff to you. In all fairness, most programmers don't know how to explain this stuff either. They may understand it, but they don't know how to explain it very well. Anyway, this pointer allows the computer to allocate memory for this thing, FP, which I'm telling it is a file, without knowing how big that file is going to be. How that works, I have no idea. Here we just have another file, fp2. We're going to assign fp to our log file, and we're going to make fp2 be our parameter file. Then we have a font. The reason that I have to use a font is that the font that by default comes with Allegro is horrible. So it does also have another font which is a little bigger, so it's a lot more readable. And then a bitmap, again a pointer to something called buffer that I'm going to use to make buffer into a bitmap that I can draw images on. All right, this bit of code right here initializes the Allegro library and all of the handy things that come with it, like the timer and the mouse routine and the keyboard routine and so on. Okay, and here we are defining buffer as I want you to create a bitmap, make it this big by this big, and then I want you to clear that bitmap to the color, make that color 0, 0, 0. The way color works here, that's red, green, blue, RGB, and I just want it to be 0 on all those 3 channels so that it's as dark as it can be. So this is basically a blank palette now, a blank screen. Here we open up the log file. If the log file does not exist, then this fopen command will create it. If it does already exist, it will open it, and then it will do whatever I tell it to do here, and my options are A for append, R for read, W for write. If I use W, it will overwrite anything that's in the log file. If I use R, it will only read what's in the log file. It won't write to it at all. So A for log files is always good because that will write new data, but it will not overwrite any old data that might exist on that log file, and that way you're never in danger of erasing data accidentally by running the program. It can create other problems in trying to figure out which subjects, which data belongs to which subject, but at least you don't lose data. Okay, and then the other file is my parameters file. I'm going to open that. Then now the parameters file must exist. Whereas log file, if it doesn't exist, I can just create it. The parameters file must exist for my program to work. So if it doesn't exist, I'm going to give myself an error that I can't open that file. Then I'm going to read in those parameter values here. Load my font. Here's where I randomize the trials. This code I took from the guy who taught me how to do programming, who taught himself how to do programming. I have gone through this little piece of code a million times, can't quite figure out how it works, but it works. It randomizes the order of trials. Here we generate a random intertrial interval so that the subject can't predict when the target's going to happen. Then we put in a little pause so that once we start the program, it actually doesn't start presenting stimuli until we tell it to by pressing a key. And this allows me to do things like go ahead and start the software, then explain to the subject what the task is going to be, and then say, okay, are you ready? Push a button when you're ready to begin. But then I don't want it to start flashing lights immediately or beeping sounds, whatever it is. As soon as they hit that button, I want to give just a little bit of a pause so that they can hit the button, get their eyes on the screen, and start going. All right, then we have a loop. This is called a for loop. So the for loop is going to start by setting I equal to 0. I is just our counter. It's then going to increment I by 1 every time it goes through the for loop. And as long as I is less than the number of trials I have, it's going to continue doing this for loop. As soon as I is equal to the number of trials I have, it's going to stop. Okay? I'm not going to go into detail about what we're doing in here. You can see the comments here that give you all that. Here are our actual trials. I mark for myself the end of that doing the trials loop so that I know where that stops. Here I'm going to save the data, and then I want to close the files that I've opened. If I don't do that, then I can have a memory leak, which is basically where we have an open file but no program is claiming that file, and so no program can close that file, and it starts taking up memory that the CPU then cannot use for other things, and it can cause problems. Your computer can slow down, it can even crash. Then the only way to close those files at that point is to restart your computer. So we want to make sure and be careful to close our files when we're done, close out any of the functions that Allegro has opened and used, and then this returns 0. Just tells the computer that the main program is now over. The main function is now over. All right, now we have the trial function. Again, variable declarations, a bitmap so we can draw stuff, which I don't actually think Starter ever uses this buffer, but you want that little piece of snippet of code because there are times when you need to draw to a buffer, or sometimes even 2 or 3 buffers in order to get your timing right, especially if you're drawing complex visual stimuli. We're going to define the color we want to make our dots, the color we want our background to be. We want our target color declared here, but we want it different depending on whether it's red or green, so we use an if-else statement. The location where we want our target presented, our fixation spot, now actually present the target, wait for a response. If we don't get a response during the time of the target, which is very unlikely we will because the target is only on for 50 milliseconds, but still, just in case. But if we don't get a response, then we're going to have a period of time after the target where we can wait for a response for a little bit longer. In this case, however long timeout doer is, I think I have it set to 2,000 milliseconds, so 2 seconds right now. And then once a response is collected, return that response. Okay, so there's our brief introduction to the starter.c code. The next video we'll actually do our first task, which I think is to change the size of the target. Alrighty. Yep, there we go. I'll